In this video lesson, we'll look at query optimization in Snowflake. Snowflake processes extensive data through queries. To ensure swift query execution, optimization techniques come into play, and Snowflake employs various strategies for this purpose. We will explore three query optimization techniques: caching, clustering, and search optimization. Before looking at query optimization techniques, it's worth considering the underlying Snowflake architecture and explaining where Snowflake caches data. Snowflake's architecture divides Snowflake into three layers: database storage layer, query processing or compute layer, which comprises of virtual warehouses, and the cloud services layer. The actual data is stored in the database storage layer. However, the data is cached in both the query processing or compute layer as well as the cloud service layer. The service layer accepts SQL requests from users, coordinates queries, manages transactions, and returns results. Storage in this layer holds the Snowflake query result cache and the Snowflake metadata cache. Metadata and result cache holds the cached results set of every query executed in the past 24 hours. These are available across all virtual warehouses, and results returned to one user may be used by any other user on the system provided they execute the same query and the underlying data remains unchanged. Compute layer does the heavy lifting. This is where the actual SQL queries are executed. At this layer, storage is implemented using high-speed SSDs and is known as either the Snowflake data cache or the warehouse cache. The compute layer uses the local disk cache to cache data used by SQL queries. Whenever data is needed for a given query, it's retrieved from the remote disk storage and cached in SSD and memory in the compute layer. Data retrieved can be used by virtual warehouse queries. When data is loaded into Snowflake, Snowflake reorganizes that data into its internal optimized, compressed, columnar format. Snowflake stores this optimized data in the storage layer. The storage layer holds the long-term storage for our data, referred to as a remote disk storage. Remote disk storage is responsible for data resilience. Moving on to the next query optimization strategy, clustering. In order to improve the performance of certain kinds of queries, you can enable clustering on tables. Clustering entails automatically sorting and organizing data in tables based on specific columns, referred to as the clustering key. Snowflake's clustering is a fully automated process, and when you designate one or more columns as the clustering key, the data is automatically reorganized as it's updated, deleted, or modified. For instance, if you choose the city column as the clustering key for your data table, all records sharing the same city will be grouped within the same micropartition, greatly enhancing query performance for operations involving the city column. It's important to note that enabling clustering incurs additional expenses, both for the initial clustering process and for maintaining it as the table evolves. Regular reclustering of a clustered table is necessary to maintain optimal clustering, especially when DML operations like insert, update, delete, merge, or copy are performed, which may affect the table's clustering. Reclustering helps preserve the benefits of clustering by ensuring that related data remains co-located within the table's micropartitions. Reclustering in Snowflake is automatic, no maintenance is needed. While clustering can significantly boost query performance and reduce costs for certain queries, keep in mind that the compute resources utilized for clustering consume additional credits. Therefore, it's advisable to employ clustering selectively, focusing on situations where the benefits to query performance are substantial compared to the cost of clustering. Clustering in Snowflake offers significant advantages for query performance and storage efficiency. Clustering allows queries to skip irrelevant data, making them faster and more responsive. Tables with clustering achieve better column compression, particularly when there is strong correlation among columns in the clustering key. Snowflake takes care of ongoing maintenance, ensuring optimal clustering without manual intervention. And finally, the third optimization technique that we will discuss is search optimization that is performed using Snowflake's search optimization service. Search optimization in Snowflake is a table-level property that users must explicitly activate for their tables. It's not enabled by default. Once enabled, Snowflake employs an additional persistent data structure that acts as an optimized access path for all records in your table. This data structure is initially populated during activation and continuously updated in the background as your table evolves. Search optimization excels in improving the performance of specific query types, particularly for equality searches. However, it doesn't enhance the speed of range searches. The advantage lies in its comprehensive optimization across all columns of supported types within a table, eliminating the need for selective column choices for optimization. The search optimization service in Snowflake is designed to significantly enhance the performance of specific query types, including point lookup queries. These are queries returning a small number of distinct rows, ideal for critical dashboards, data exploration, and data applications with selective filters. Substring and regular expression searches, queries involving operations like, I like, and relike. Queries on special data types, including variant, object, and array columns, using predicates like equality, in, array_contains, arrays_overlap, substring, regular expression, and null checks. Geospatial queries, queries leveraging selected geospatial functions with geography values. Once you've identified the queries that stand to benefit from this service, you can configure search optimization for the specific columns and tables used in those queries, leading to improved query performance and efficiency.
Thank you so much for tuning into today's video. If you enjoyed this video and found it helpful, please consider giving it a thumbs up by clicking the like button below. And if you haven't already, we'd love for you to subscribe to our channel by clicking the subscribe button and ringing that notification bell. This way, you won't miss any of our future updates.